Consider the equation 2x squared minus 7x plus 3 equals 0. Okay, that's quadratic. It opens up, and so it's going to have a U shape generally. Exact location to be determined in a bit. Describe how the zero feature of a graphing calculator can be used to determine the roots of the equation. If you're talking about the TI-83, then you'd be using second trace to get into the calc menu. First you would have to graph this, then use second trace to get into the calc menu and select 0. When you do that, it's going to ask you to put in a left bound and right bound to tell it where to look, and then it'll search in the range that you've given it and try to find a 0 for the equation. So here's a TI. Let's see if we can do this. The equation, you go to y equals to plot it, is 2x squared minus 7x plus 3. Enter. If you graph it, sure enough, it's a parabola. If you want to find zeros, there are two. One is right here. One is right here. Because some curves can have 2 or more zeros, you have to tell the calculator where to look. When you go second trace and then tell it to find a 0, you have to put in some marks to tell it what region to search in. Right now it's saying left bound, which says put a mark somewhere to the left of the point you want me to find. I want it to find this point, so where it is right now is actually a little bit left of that. That's fine. Enter. It puts a little mark up here saying there's your left bound. Now it says show me the right bound. Using your left and right arrows, you can move until you're a little bit to the right of the point you want it to find. Enter again. Now it's got these two marks pointing in saying I'm going to look between these marks and try to find a 0. Then it says do you have a guess? No, I don't. Enter. And it eventually finds that 0.5 is one of our zeros. If you want this 0, you get to do all that again. So second trace 0. Now, if you want the left bound, go somewhere like here, somewhere that's just a little bit to the left of the point you want to find. Enter. There's our left mark. Now it says show me the right bound. Move over to the right side of the point you're trying to find. Enter. And now it's got these two marks. It's saying it's going to look in this area between the two arrows to try to find a 0. Enter one more time for the guess, and it comes up with 3. So, determine the roots of the equation. We found them. They are x equals 0.5 and x equals 3. Sketch the graph on the grid. We had an intercept at 0.5, an intercept at 1, 2, 3, and the curve went something like this. Notice how I sneakily put this point in there? This is the y-intercept. I won't take you through the work, but see if you can figure out how, from a quick glance at this equation and virtually no calculation at all, I was able to tell that the y-intercept was 3. Good skill to have, and I will show you in one of the later examples. Use the x-intercepts on the graph of to factor the expression. Well, if 0.5 is a root, that means x minus 0.5 has to be one of the factors. If 3 is a root, then x minus 3 has to be one of the factors. Now, this decimal is clearly not something that they intended. There aren't any of those in the expression that they gave, so there must be some other way of writing this. There certainly is, in fact. Instead of 0.5, you can say this is x minus 1/2. And if you don't like the fraction, the way you can fix this is multiply that entire factor by 2. So you get 2 times x and 2 times 1/2. There we go. Both of these involve the same root. It's just here you're writing it in fraction form, here you're writing it in what they call integer coefficient form, where all of these are whole numbers. So if this had a factored form, I trust it would be 2x minus 1, that comes from our first root, times x minus 3 from our second root. And let's make sure that actually worked. If you FOIL this, you get 2x squared minus 6x and minus another x is minus 7x. And negative 1 times negative 3 makes plus 3. So, excellent, it worked. What are the zeros of the function 2x squared minus 7x plus 3? We found them a while ago. We've been calling them roots in this question, for a lot of it anyway. But zeros, it's the same answer. 0.5 and 3.